Okay, class, in this lesson, we are going to learn to determine congruent triangles by comparing two angles and one side. So let's go ahead and get started. So in this theorem, angle side angle, what we see is that if two angles of one triangle and the included side, so two angles, so this angle here, these two angles and the included side, let's say that they are congruent to two angles and the included side of another triangle. Okay, so these two and the included side. If that is the case, then we would say that both of these triangles are congruent. Okay, now let's go ahead and take a look at an example to try this out. All right, so in applying what we just saw earlier in the theorem, which was called the angle side angle congruence theorem, we have a problem here where a technician installs cables from a cell phone tower. Okay, here's a cell phone tower, and the cables are connected from the tower to the ground. Okay, now to pass inspection, both cables, so this length right here and this length right here, must be the same. Okay, so the question is, does this installation meet the cable length requirement? Okay, so what I've drawn here to the right is a replica, okay, of the diagram. Okay, and you'll see that I've labeled these triangles A, B, C, as well as D, B, C. Okay, you'll notice that these angles, angle ABC is 52 degrees and angle DBC is also 52 degrees. And we have to determine if those lengths are the same. Okay, so to do that, what we essentially need to do is to prove that triangle ABC is congruent to triangle DBC. Well, let's first identify some congruence. So we know that angle ABC is congruent to angle DBC. Okay, and we also know that segment BC is congruent to segment BC. Okay, so if you notice, segment BC is shared by this triangle ABC as well as this triangle DBC. And then we see that angle ACB is also the same as angle DCB. They're both right angles. Okay, so we would say that angle ACB is congruent to angle DCB. Okay, so therefore, and these three dots means therefore, triangle ABC is congruent to triangle DBC by angle side angle. Okay, and because both of those triangles are congruent, then we would say that side AB, which is the cable, and side DB, which is the other side of the cable, are exactly equal. Okay, so let's move on to the next theorem. This is the angle side theorem. And basically what this is saying is that if two angles, so we've got these two angles here, and a non-included side of one triangle, if they're congruent to two angles, so we've got this angle here and this angle, and a non-included side of another triangle, then we would say that the two triangles are congruent. Okay, so this is called the angle side congruence criterion. All right, so let's go ahead and move on to example 2. So we've got 4 pairs of triangles here, and we need to identify if they are congruent, and if so, how are they congruent? Okay, so let's take a look at this first pair. We see that this triangle has an angle side angle, and we also see in this triangle an angle side angle. Okay, and we see that they're congruent on both sides of the triangle, so we would say that this is congruent by angle side angle. Okay, and let's take a look at this next pair. We see that side, side, side are also congruent to side, side, side. Notice the markings. We got 1 hash, 1 hash, 2 hashes, 2 hashes, 3 hashes, 3 hashes. So those are congruent by side, side, side. And then if we take a look at the next pair, we have an angle, angle, side, okay? And this angle is congruent to this angle is congruent to this angle, and this side is congruent to this side, and so we would have an angle, angle, side congruency here. Okay, so this would be angle, angle, side. And if we take a look at the last pair, we see that this triangle has a side, angle, side, okay? However, we have a angle, side, side. Not quite exactly consistent, and so we would say that this is not congruent. Okay, so let's move on to example 3. Okay, here we're asked to find the value of x, and in order to do that, we have to determine first if triangle ABC is congruent to triangle PQR. Okay, well, we see that angle B is congruent to angle Q. We also see that angle C is congruent to angle R, and then side AC is congruent to side PR. Okay, so we have an angle, angle, side scenario, so we would say that they are congruent. And because they are congruent, we can safely say that side AB is the same as side PQ. Okay, so that means x plus 4 is equal to 7, and x works out to be 3. Okay, and let's take a look at this next example. We have a triangle DEF and triangle XYZ. Sorry. You'll notice that this has an angle of 23, and this also has an angle of 23. And we have a side that is 13.5 feet, and then this side that's 13.5 feet, and then this angle that's 64 degrees, and this angle that's 64 degrees. So what we have here is an angle, angle, side scenario for triangle DEF, and same for triangle XYZ. We have angle, angle, side. So based on those parameters, we've determined that both of those triangles are congruent, and because they are congruent, then all of the sides are also congruent. So what that means is, in solving for x, we could say that 4x minus 1 is equal to the corresponding side of this triangle, which is 15 feet. So setting that to 15, we can now solve for x. 4x is equal to 16, and dividing 4 on both sides, we find that x is equal to 4. Okay, so that is the solution for this example. And let's move on to example number 4. So now we've moved beyond the triangles, and now we have a 4-sided figure. And the question here is LMNO congruent to PQRS? Okay, so the way to figure this out is we're going to draw a dotted line from L to N. Let me go ahead and make that dotted. And then we're also going to draw a dotted line from P to R. And what you'll notice is that when we draw these dotted lines, it creates two different triangles. We have LON and LMN, and then on the other figure, it creates a triangle PRS and PQR. Okay, so let's go ahead and compare these triangles. We see that with LON and PSR, okay, LON, and PSR, we see that we have this side, LO, with 3 hash marks and PS with 3 hash marks. So those sides are congruent. Then we also have angle O, which is a perpendicular angle, or 90 degrees, and angle S, that's a perpendicular angle, or 90 degrees. And then we also have side ON with 4 hash marks and side RS with also 4 hash marks. Okay, so then what we notice then is that both LON and PSR are congruent. Let's go ahead and write that down. Triangle LON is congruent to triangle PSR, and they're congruent by side angle side congruency. Okay, so at least we know part of that 4-sided figure is congruent. Now we have to look at the other side. Okay, we're going to look at triangle LMN, okay, LMN, and triangle PQR. Okay, so we have side LM with 1 hash mark, and that is congruent to side PQ with 1 hash mark. And then we have this marking at angle M telling us that it is congruent to angle Q. Okay, and then we also have side MN with 2 hash marks, and that is congruent to side QR with 2 hash marks. Okay, so then what we find is that triangle LMN is congruent to triangle PQR, and they're congruent by side angle side congruency. Okay, so because both sets of triangles are congruent to each other, then we could say, and again these 3 dots means therefore figure LMNO is indeed congruent to figure PQRS. Okay, hopefully that made sense. If you have any questions or if anything was unclear, please go back to the beginning of the recording and listen to it again. Thank you.